Hi, my name is Sainath Reddy Pingili and my student ID is S22468764 I'm presenting you my assignment of red wine quality prediction using aggregation models from the unit SIT718 Real World Analytics. In this assignment, it is divided into four tasks. The task one we do is understanding the data and visualization. In the task two, we transform the data, and in the task three, build models and investigate like applying different aggregation models. And finally, in the task 4 we predict the wine quality. Upon coming to the task 1, the dataset introduction. Here in our dataset, it consists of 1599 samples with various chemical attributes, and the target y variable represents wine quality rated from 0 to 10. And in out of 1599 samples, we select randomly 460 samples using a fixed random seed derived from my student ID, and this is unique for each and every student because they have different student IDs. In the task 1, we need to perform two separate tasks. One is scatter plots, and we need to find histograms. In the scattered plots are used to observe potential linear or nonlinear relationship between each input variable from x1 to x5 and the wine quality phi. Below you can see the R script for our scatter plots. Here we use two rows and three columns. For I in 1 to 5, here we plot 5 scatter plots. Here are our 5 scatter plots, and this is unique output for each and every student because we are randomly selecting 460 rows or samples from a student ID, which is a unique ID. And now it's a histogram. Histograms were plotted for each of the 5 input variables, and the target to assess the distribution and skewness of the data. Below you can see the R script for our histogram code. Here the same, we uses two rows and three columns, but here we print 6 histograms, I in 1 to 6. And here is the output for our histograms. This is also unique for each and every student because we are randomly selecting 460 samples. Upon coming to the task 2, here we randomly select 4 variables. I chosen like x1, x2, x4, x5, citric acid, chlorides, pH, alcohol. x3 was excluded due to the poor correlation or redundancy. These variables were chosen because they had a logic or statistical relation to wine quality. Our main aim of task 2 is to apply transformation to each and every variable. For x1, I applied log transformation, x2 square root, x4 stand z-score, and x5 square to enhance variation. And for the y, I applied min-max normalization. These transformation ensured a balanced and comparable input range. And below you can see the R script for each and every variable, and the normalization technique is crucial for aggregation models. Min-max scaling was applied to each variable to scale values between 0 and 1. And here at the end of the task 2, after successfully executing all transformation methods, we get the final output as x1, x2, x4, x5 and y. The final transform dataset consists of 460 observation across 5 columns, 4 predictors and 1 target file. Here below you can see our output of transform dataset. And upon coming to the task 3, here our main aim is to perform aggregation models for each and every variable. Here we perform 4 aggregation models: WAM, WPM with power 0.5, WPM with power 2, and OWA. These models aggregate input variable to predict the normalized wine quality. And here, after successfully executing, we can see the model performance metrics. Each model was evaluated using standard regression metrics. RMSE, MAE, Pearson correlation, experiment correlation. The WPM model 2 is performed well among all those. Here below you can see the output results. In these, WPM2 has low error 0.191, 0.149 among all others, and has high correlation 4.21 and 4.430. Upon executing, we will get two output files for each and everything. Uh, Here for WPM2, the output .text file has actual versus predicted, and for WPM2 statistics, .text file consists of error matrix and variable value. These were used for next predicting the final output. Here we can see the training models using fit.qm quasi function. The first we're training WM, and the next script is training WPM with a p equals to 0.5, and next p equals to 2, and at the end of the script that is training OWA model. Variable importance of WPM2. Here we have four variables, and in that x2 has a 0. It has no impact with our output. X1 and x4 has highly influenced our output, and x5 is a moderate. And the summary of our task 3 is WPM2 was selected because it has low error and strong correlation among all others. And upon coming to the task 4, a new data point was introduced with the following values of x equals to 0.8, x 2.63, x4 2.5, x5 7. These were transformed and normalized using the same rules as we applied in the task 2. The prediction methodology. The transform input was plugged into the power mean formula with a p equals to 2. The weights used were directly from the WPM2 stats which we executed in the task 3. The output y was still in a normalized scale. Here below you can see the script of making the prediction using power mean p equals to 2 formula. And the final prediction output, after inverse normalization of y to its original range, the predicted wine quality was approximately 6.3. Upon rounding the nearest integer, we get the predicted quality score was 6. Here below you can see our exact output upon executing our final code. Here predicted wine quality y equals to 6. This is the end of our task 4. And upon coming to the insights from the prediction, the most impactful variable were citric acid x1 and x4. Alcohol also played a role. The prediction aligns with the expected trends, showing higher alcohol and acidity generally lead to the better wine quality. And coming to the limitations and ethical aspect, the model uses only chemical data and misses key sensor factors like taste or aroma. It may not perform well on different wine types outside the data set. And upon coming to the issues, the dataset was provided exclusively for verified Deakin students only as a part of SIT718. Since it contains no personal or sensitive information, there are no data privacy issues involved. In further model, with the user data, ethical handling and consent would be essential. By the end of this presentation, the references which we are using are the data sets. I got it from the Deakin University, Cloud Deakin, in the resource section, and the packages we are using are E1071 for QNS, LP and custom script provided, that too from the resources, and the template is also from the resources. And this is the end of my presentation. Thank you.